Hello students, now we're going to do conversion factors using Avogadros number. That's the number for the mole, 6.02 times 10 to the 23rd. Woohoo! But first, a review from last class, doing one more molar mass conversion problem. So if we have 25 grams of water, how many moles of water do you have? Well, step number one, what are you solving for? It's asking how many moles of water, so we need to put moles of H2O right here, leaving space for a value. Step number two says, what are you asked to convert? It looks like we're asked to convert 25 grams of water. The question says, if you have 25 grams of water, how many moles of water do you have? So it's the 25 grams of H2O that needs to be converted. And right in here is the molar mass conversion factor, where we need to convert from the unit grams to the unit moles. So the grams needs to be canceled and the moles needs to be kept. So how do we know the correct numbers, the correct values to put in those spaces? Well, we have to know that there's 2 hydrogen atoms and 1 oxygen atom in the molecule H2O. And then we take 2 times the molar mass of hydrogen, which is found on the periodic table. The molar masses of each of the elements are found on the periodic tables. Then we add that to 1 times the molar mass of oxygen on the periodic table. And that equals our molar mass of our molecule. And by now you should start memorizing that the molar mass for water is 18.02 grams per 1 mole. So we put the 18.02 right here and the 1 mole on top. Now we know that we have to do some math. And how we do the math is we take what we're trying to convert and we multiply by the conversion factor. That means multiplying across the numerator and dividing by the denominator. Since I don't have to multiply by 1, I'm just going to divide by the 18.02. So let's start with 25 divided by 18.02, push equals. That's 1.387, so we're going to call that 1.39 if we're rounding correctly. So 1.39. All right, that's a review from last class. You should be getting really great at that. Okay, now let's learn new things. Well, they're not really new, but it's kind of new. Okay, so the new thing that we're going to learn is this right here. Avogadros number of particles conversion. So Avogadros number is the number for the mole. The Avogadros number is the number for the mole. Here's a review. Here's a few different words that mean different numbers. So a few could be 2 or 3. That's like a few. A dozen is 12. We could be talking about eggs here. We could be talking about anything. 3 of anything is a few of anything. Here's another word, a gross. You probably haven't heard of that one, but that means 144. Well, the word that you should know for chemistry class is mole. This word means this number, which means you'll be seeing this a lot. 6.02 times 10 to the 23rd. It could be atoms or molecules per 1 mole. That'll be what the conversion factor looks like, that way or flipped upside down. Okay, so these are examples of different substances. This is mercury 2 oxide. This is sucrose. That's just sugar. Here's sulfur. Has a yellowish color. Copper 3 sulfate pentahydrate. It's this blue powder. Copper pellets. And sodium chloride, good old table salt. You can see the crystals that make up all of these, most of these ionic compounds, with the exception of copper being the metal and sucrose being the covalently bonded molecule. But you can see that there's crystals, but you can't see the individual atoms. And that's why we have a number that's just so big so that we can count the individual atoms. Remember, a mole is so large that if you had 1 mole of basketballs, that would be like an entire world of basketballs. That'd be like the entire Earth. The entire Earth of basketballs. Woohoo! So what does all of this mean? It just means one simple thing. What do we take from all of this? That atoms are very small. Atoms are extremely, extremely small. That's why we need such a large number to talk about them and calculate with them. All right, let's do some practice problems. Here it goes. So using the Avogadros number, which is 6.02 times 10 to the 23rd particles per mole, we're going to convert the following questions. Okay, we're either going to use this one or this one. We'll call this A or B, and I'll ask the question. So step 1, what are we solving for? The question says if you have 1.45 times 10 to the 25th atoms of nitrogen gas, how many moles of nitrogen do you have? So we are solving for moles of nitrogen. Step number 2, what are you asked to convert? Well, it looks like we need to convert atoms into moles. So we're going to put the correct number on this side. That's atoms of nitrogen. Okay, now it's up to you. Well, which conversion factor should we use? A or conversion factor B? Whenever you're converting particles like atoms into moles, or if you're converting moles into atoms, you're going to use either A or B conversion factor. Okay, if you said B, you got the correct answer. This is the correct answer right here, not A. I don't know why I put a check mark there. Let's erase that. B is the correct answer for this problem. So we put it in exactly like that. You could use shorthand if you'd like. 1 mole over 6.02 times 10 to the 23rd. And we don't have to write the word particles because we know it's atoms. It's atoms that we want to cancel. Okay. Now when we put this into the calculator, we need to use parentheses. Okay, I'll show you 2 different ways. Okay, so parentheses 1.45 times 10, and then you use this little caret button. That little caret button to the 25th power and the parentheses. And since we're multiplying by conversion factor, that means we multiply across the numerator and divide by the denominator. We don't really need to multiply by 1, so let's divide by the bottom number. Push division, and then use parentheses again whenever you have a scientific notation number. 6.02 times 10, caret to the 23rd button, and the parentheses. And that will show you the correct answer, 24.086. Let's call that 24.09 if we round correctly. 24.09. All right. There it is, folks. That's how you do these problems. Let's do one more example before you start to do the worksheet. All right, here is the example. One moment, that vacuum is bothering me. Okay, here's the example. The question says, if you have 12.5 moles of chlorine gas, that's moles, not liters, not grams, that's moles. How many atoms of chlorine do you have? So step number 1, what are we solving for? The question's asking how many atoms. So we need to put atoms of what substance? Yep, that's chlorine, Cl2. Okay, we're going to leave a little space right there for our answer value. Step number 2 is, what are you asked to convert? The question says, if you have 12.5 moles of chlorine, how many atoms of chlorine do you have? So we're converting 12.5 moles into atoms. Okay, so which conversion factor are we going to use? A or B? Okay, if you answered A, you got it correct. Good job. Okay, so let's put the number in there correctly. 6.02 times 10 to the 23rd. Those are atoms per every 1 mole. You see the moles get canceled. The mole gets canceled, and you're left with atoms, and that's the unit that we want to solve for, so we're doing a good thing here. Okay, here's another way you could use the calculator to get the correct answer. There's this function called EE right here, the little EE in blue. That means you have to use the second option on the calculator. So it looks like this. 12.5, and we're multiplying across the top of the conversion factor, the numerator, and we're going to divide by the bottom. We don't really need to divide by the bottom because the bottom number is 1. So we're going to multiply, and this is how you don't have to use parentheses. 6.02, then you have to use that EE function. So you have to push the second button first, and then EE. Looks like that. And then you can just put 23, and that EE means times 10 to the power of. So when you push equals, that should be the right answer as long as I put everything in the calculator quickly. So 7.525, so let's call that 7.53 times 10 to the 24th. 7.53 times 10 to the 24th atoms of chlorine. And that's it. That's how you do these problems. Now I want to give you a warning. The next worksheet is going to be called 2-step conversion problems. And you are going to need to decide which conversion factors you need to use, and there's going to be 2 steps. So I wish you the best of luck, and good luck on the assignment. Bye.